Today we're going to talk about average rates of change. But in order to understand average rates of change, we need to do a quick review about rates of change themselves. So we're going to start by going on a little jog. The first length of our jog is going to happen at a steady 6 miles per hour. We're going to take our distance for a half a mile at that pace. When we're done with that first half mile, we're going to take our next leg at a quarter of a mile at a sprint pace. I find that for no reason in particular, we'll do the last quarter of a mile a little slower than before. Now let's get talking about rates of change. For our particular run, you can see the graph. This graph shows the 4 different parts of our run. And the pace or speed of each of these, or rate of change, was given by the slope from each section. Now to find the average rate of change, all we do is go directly from the first to the last point, and we find the slope pretending that it's a single straight line. Essentially, we're pretending that we went the exact same speed throughout the whole run. In this example, we went 1 mile, so our rise is 1, and it took us 0.234 hours to do this run. If we put that in slope form, 1 divided by 0.234 gives us 4.27 approximated for an average speed or average rate of change of 4.27 miles per hour. Now let's do another couple of examples. Our first one here gives us an equation and asks us to determine the average rate of change of the function. And it gives us a starting and ending value. Here our starting value is -5 and our ending value is 2 for our x's. So let's go ahead and take a look at what that graph looks like. Here we have the function graph, and we can see that there is not a constant rate of change from one end to the other. And so we are going to find the 2 points that we're interested in and see what the average rate of change is from those. So the first point that we're looking for is this A point right there. And then the second point we're looking for is B. We get those by plugging in the -5 for the x and plugging in the 2 for the x, and we find the y values. Now the two y values respectively are -2 and 19. So we are going to again pretend that it is a perfectly straight line from one point to the other, and we are going to find the slope of that line. To find that slope, we need to find the rise, and we need to find the run. And we can see that this rise right here, segment H, goes from -2 to 19 for a rise of 21. And our run goes from -5 to 2 for a total of 7. 21 up, 7 over would give us a slope of 21 over 7, or 3 if we simplify that. So that is our average rate of change for this example. The next example, I'm not even going to draw a full graph. I'll draw a little bit of it, but we're given some information here that the bacterial population is changing over time. So it starts at 3 days in, gives us a total of bacteria, and then ends at 12 days in and gives us another total which is higher. So if we were to draw a rough graph of this, we start at 1, 2, 3 days in. The bacterial population at that point was 54.1 thousand. We go all the way to 12 days, and the bacterial population increased to 70.1 thousand. So we started here, we ended here. Now I have no idea what happened in between here and there. It could have gone up, it could have gone down, it could have done all sorts of different things. But again, for our purposes, we're pretending it's an exact straight line. All we need to do is find our rise, find our run. And so we go from 54.1 to 70.1. We just do 70.1 minus 54.1. That gives us change or a rise of 16. And then from 3 to 12, our run goes 12 minus 3 is 9. So 16 for our rise and 9 for our run. 16 divided by 9 ends up not being a nice number, but that would be our average rate of change. And if you need to approximate it with a decimal, you can put that into a calculator or simplify it as needed. Thank you and good luck.